The views expressed on Science for the People are not necessarily the views of this station, its affiliates, sponsors, or advertisers.
Welcome to Science for the People. Today on the show, we'll be talking about math and science that appears in seemingly unusual places, and ways you can get your math and science on in places you might not expect. Welcome to Science for the People. I'm Rochelle Saunders. Later on in the show, Desiree Schell will be talking with Chris McKinlay, the PhD math student who notoriously math hacked the OkCupid dating website to boost his chances at finding his perfect match. And I'll be speaking with Kenji Lopez-Alt, the Chief Creative Officer at Serious Eats and writer of the award-winning column The Food Lab, about how he used the scientific method to create the perfect chocolate chip cookie. But first, let's talk with author Simon Singh about his newest book, The Simpsons and Their Mathematical Secrets. Simon Singh received his PhD in particle physics from the University of Cambridge. A former BBC producer, he directed the BAFTA award-winning documentary Fermat's Last Theorem and wrote Fermat's Enigma, the best-selling book on the same subject. He has also written The Code Book, Big Bang, and Trick or Treatment, the undeniable facts about alternative medicine. Welcome to the show, Simon.
My pleasure. Good to talk to you.
So, The Simpsons and math, that's a pretty specific topic. What prompted you to write the book?
About 10 years ago, I was watching an episode called The Wizard of Evergreen Terrace, where Homer wants to become an inventor. And he's in his basement, busy inventing. He's scribbling some equations on a blackboard. And amongst the equations, there's a reference to Fermat's last theorem. And as you mentioned in your introduction, I've written a book about Fermat's last theorem. I've made a film about Fermat's last theorem. So when Homer Simpson writes up an equation about Fermat's last theorem, it really kind of stops me in my tracks. So I started thinking, well, who was responsible for that? Which of the writers likes maths? And when I did a bit of digging, it turned out that actually there are lots of the writers on The Simpsons who love maths. There are writers on The Simpsons who have degrees in maths, who have master's degrees, who have PhDs, who've written research papers. And they've all been, really from the very first series, they've all been putting in these little mathematical references, which I hadn't noticed prior to that moment. But I then started searching through the episodes, looking for these different references. And that's the connection.
This all really makes a lot more sense if everyone understands the credentials behind a lot of the writing staff on The Simpsons. Can you give us a quick overview of what kinds of credentials we've got on that show?
Yeah, well, I think if you look at the very, very first series, going back to kind of 25 years ago almost, you have somebody like Mike Reese, who didn't actually study for a degree in maths, but was on the maths team in high school, who corresponded with Martin Gardner. I don't know if listeners are familiar with Martin Gardner. It's his 100th anniversary, or the 100th anniversary of his birth this year. He died just a few years ago. But he's one of the greatest recreational puzzlers of the 20th century. And Mike Reese was corresponding with Martin Gardner as a teenager. And so Mike Reese has an interest in maths. He was on the maths high school team. He corresponded with Martin Gardner. And he was a writer on the very first episode and the very first series of The Simpsons, and has really been working on The Simpsons ever since. Alongside Mike Reese on that very first series was Al Jean. Al Jean was so brilliant at mathematics that he went to Harvard when he was only 16 to study mathematics. So absolutely, a superb young mathematician. And again, he's worked on the show for 25 years, more or less. People like J. Stewart Burns was doing a PhD in pure mathematics at Berkeley and quit his PhD halfway through in order to become a comedy writer. Ken Keeler was doing a PhD, or completed a PhD in applied maths. And then was a researcher at AT&T Bell Laboratories, a place that's had over a dozen Nobel Prizes. Quit his job at the lab in order to become a comedy writer. The list really goes on and on.
You mentioned previously Homer writing down Fermat's last theorem, and that reminds me that was actually sort of part of a quite elaborate math joke that the writers played on the watchers.
So the person behind that reference is somebody who we haven't mentioned yet, a chap called David S. Cohen. He later changed his name to David X. Cohen, so you'll see him credited either as S. Cohen or X. Cohen. Either way, it's the same David Cohen, the same guy who has a degree in physics, who has a master's degree in computer science, and who's written mathematical research papers. When he introduced this reference to Fermat's last theorem, what he's done is the following. Fermat's last theorem says that you'll never find a solution to the equation x to the n plus y to the n equals z to the n if n is bigger than 2. Okay, now people don't need to worry about that too much, except that there is an equation which has no solutions. There are no whole number solutions for this equation. Pierre de Fermat said that 350 years ago. More lately, Professor Andrew Wiles proved again there are no solutions to this equation. And yet Homer Simpson writes down a solution to that equation. So Homer Simpson in The Wizard of Evergreen Terrace is defying all of mathematics by finding a solution to this equation. And if you check it on your calculator, if you have a phone calculator and you just put in the buttons, you push the buttons and check the equation, it works. The equation balances. It seems that Homer is correct. So how can Homer be correct and all of the rest of the mathematical world be wrong? Well, the trick that's been played is that the solution that Homer comes up with is known as a near-miss solution. That means that it's a solution that looks very close to being correct. It's so close that it will fool your telephone calculator. But if you have a calculator with more digits, a longer display, you notice that at about I think about 9th or 10th decimal place, there is a slight discrepancy. The equation doesn't balance. And so David X. Cohen, who created that reference, 1, he knew about Fermat's last theorem. 2, he knew it shouldn't have solutions. 3, he discovered a near-miss solution. And 4, that near-miss solution was so clever that it fooled a lot of people. So that's the level, the extent to which the mathematical references are probing at the kind of some of the more esoteric ideas in mathematics. Fermat's last theorem crops up in Star Trek. It crops up in Doctor Who. It crops up in a play by Tom Stoppard called Arcadia. It crops up in a film with Liz Hurley and Brendan Fraser called Bedazzled. But in The Simpsons, it crops up as a really clever false solution. So the Simpsons writers kind of up the ante by going into Fermat's last theorem in much more detail than you would find anywhere else. And also, I should say, David X. Cohen mentions Fermat's last theorem in another episode called Homer Cubed, which is part of the Treehouse of Horror 6 episode. Homer is trying to hide in a closet, and he discovers that inside the closet there's a portal to a higher dimension, and he goes through the portal into a higher dimensional world. So the idea is that the Simpsons live in a 2-dimensional world because they're flat animated characters, but now Homer's entering a higher 3-dimensional world. In the higher 3-dimensional world, the animation is very different. It's kind of sophisticated computer 3D animation. And the 3D animated landscape is populated with actually lots of mathematical equations. One of them is Fermat's last theorem, just flying around in the background. But also in that episode, you find references to Cartesian coordinates, to ASCII, which is a way of translating symbols and letters into numbers. You find something called a Utah teapot, which is a way of mathematically or testing how good your mathematical modeling of 3D objects is. There's a reference to something called Euler's identity, arguably the most beautiful equation in all of mathematics. There's a reference also to P versus NP, a great unsolved problem in mathematics, all just kind of floating around in the landscape. And unless viewers really know their maths, they just won't notice it. It just looks like complex gobbledygook, but it's all there, all embedded in The Simpsons.
In addition to the straight-up math jokes, The Simpsons has also taken shots at, let's say, bad math policy. I'm thinking specifically of the Indiana Pie Bill.
There's an episode where Professor Frink is trying to get attention at a science conference. Bye Bye Nerdy, I think, is the episode where Lisa's discovered why bullies sometimes pick on nerds and geeks, and it's because nerds and geeks emit a pheromone called point dextrose. And so she identifies and isolates point dextrose, and she wants to present it at a scientific conference. Professor Frink is the chair of the conference, and he's trying to get attention for Lisa. He's trying to get some silence, some order in the room, and nobody's listening to him. So in order to get silence, he says, look, ladies and gentlemen, hush, please, quiet, please. Look, ladies and gentlemen, pi equals 3. And of course, pi doesn't equal 3. Pi equals 3.141592. I think goes on forever. It's no simple number. It's an irrational number. And that's the one thing we all know about pi. It's not simply 3. And of course, then there's a hushed silence because all the scientists in the room are shocked that Professor Frink should suggest such a thing. That reference appeared in the episode because Al Jean, who we mentioned earlier, who was the Harvard teenage superstar, the math superstar who went to Harvard when he was 16, he'd been reading a book about the history of pi and had learned that, I reckon about 100 years ago, there was an attempt in Indiana to legislate a value for pi. Okay, so instead of saying pi is an irrational number that goes on forever, let's just legislate it. And they weren't going to legislate it to be simply 3. They were going to force it to be 3.2. And the idea was brought to them, I think, by a dentist who said, look, if you pass this policy, then schools in Indiana will be able to use this for free, the value of pi being 3.2.
Oh, how nice.
And we'll charge, and they will have the audacity to charge other states for using the same value of 3.2. And I guess politicians then, as today, weren't particularly mathematical. And it got passed through various committees and was on the verge of actually becoming statute. When a professor of maths from, I think, Purdue University was passing through and pointed out this was just ridiculous and absurd. And once word got out about what was happening, then the newspapers turned and said, politicians might as well legislate for water to run uphill. So again, just a passing reference to pi actually has a very, very nice backstory to it.
Speaking of pi, so apparently Apu can recite pi to 40,000 digits. Is that even possible?
Oh, yes, yeah. No, there's an episode called Marge in Chains where Marge is accused of theft from the Quickie Mart, and Apu is the primary witness. And so when she's put on trial, Apu's put in the witness box to try and testify against Marge. And Lionel Hutz, who's the attorney working on behalf of Marge, says, well, look, Apu, you're a witness, but you're a terrible witness. You're very unreliable and so on. And Apu says, no, I'm a great witness. I have a fantastic memory. In fact, my memory is so good, I can recite pi to 40,000 decimal places. So that's where that reference appears. And again, it just seems like a very throwaway line. But the effort behind that line, again, is only there because of the writing team. And by effort, I mean, well, why 40,000 digits? Well, the world record for reciting pi when that episode was broadcast, I think probably maybe 1996, something like that. The world record was 40,000 digits. So Apu was claiming a record, which was a very, very real record for memorizing the digits of pi. Secondly, is the 40,000th digit of pi 1, which is actually what Apu claims? Well, yes, it is. And the writers knew that because they contacted a world pi expert at NASA. I think David Bailey was his name, and he actually sent them all 40,000 digits of pi so that they could be sure. And also, when I spent a week with the writers last year, and I interviewed lots of them, and I interviewed one of the writers of that episode, a chap called Josh Weinstein, and I said to Josh, that's an interesting reference to pi, but why did you put it in? Because you're not a mathematician. Because Josh actually is one of the writers who doesn't have a mathematical background, and yet in his episode there was a reference to pi. And he said that actually when he wrote a draft for that script, pi was not mentioned. In his original draft, Apu just says, oh, I have a great memory. When I was in India, I featured in over 400 films called Here Comes Mr. Memory. And he showed me the original script for that episode. And sure enough, there is no mention of pi. But writing a Simpsons episode is a very collaborative effort. And so Josh would have submitted his script to the rest of the writing team, and they would have gone through it line by line, and they would have taken out some of the weaker jokes, and they would have improved on some of the good jokes. And at that point, around that table, there would have been mathematicians, and that's when they would have introduced that line for Apu. And I said, why introduce mathematics for Apu? Why do it in that particular episode, in that particular place? And they reminded me that actually Apu is a mathematician. If you look at his backstory, there's one episode called Much Apu About Nothing. We hear about Apu's history, and he studied mathematics and science. He studied maths and science at Caltech. When I say maths and science at Caltech, when I say Caltech, I don't mean the California Institute of Technology. I mean the Calcutta Institute of Technology, which is where Apu studied. And after that, he did a PhD in computer science. So again, more kind of nerdiness in one of the characters.
This is Science for the People. Today we're talking about the new book, The Simpsons and Their Mathematical Secrets, with author Simon Singh. One of my favorite stories from your book is how one of the writers actually constructs a mathematical proof that was intrinsic to the plot of a Futurama episode. I'm thinking of Keeler's theorem.
That's kind of how I finished the book, because I can't think of anything more extraordinary than this particular piece of mathematics in the context of television, certainly. There's an episode called The Prisoner of Bender. Professor Farnsworth, who owns the Planet Express company in Futurama, Professor Farnsworth invents a mind switching machine so that two people can switch minds and enter each other's bodies. And all the characters of Futurama think this is great fun, and they all start switching minds with bodies. And even once they've switched once, they'll switch again. So there's all complete complicated mix-up of minds and bodies. And it's all great fun, but by the end of the episode, people want to get back to their original bodies. But the problem is this. Once, let's say, you and I have switched minds, we cannot switch back. There's a glitch in the machine. If you and I want to return to our original bodies, we have to do it by switching with other people. So we have to take some kind of indirect route. But it's not clear that such a route exists. It's just not obvious. And so this gives rise to a mathematical problem, which you can kind of frame in the following way. Given X number of people and given Y number of switches, is it possible for people to get back to their original bodies? And if it's not always possible, what would you have to do to enable it to be possible? And Ken Keeler, who we mentioned earlier, has a PhD in applied mathematics and who was at Bell AT&T Labs and who was one of the writers on Futurama at the time, said, well, I'm going to try and deal with this as a mathematical problem. Given any number of people X, given any number of switches Y, what do you require to enable everybody to get back to their original bodies? And he proved that if you add two fresh people into the mix, so after all the switching has occurred, if two fresh people enter the room, they provide enough flexibility for everybody else to get back to their original bodies and for those two extra people also to be returned to their original bodies. And this is known as Keeler's theorem or the Futurama theorem. Ken Keeler is very modest about it. He says it's not a great worthy piece of mathematics, but it's a very neat little proof, and other mathematicians have actually added to it and found other odd little quirks to kind of look at questions like what's the quickest way to unravel a mixed up group of people, and so on. I can think of no other TV program, I can think of no other comedy writer who has ever had to create a bespoke mathematical theorem purely to resolve a plot point. And so that's why I put that at the end of the book, because to me that seems like the most extraordinary mathematical effort in the context of either The Simpsons or Futurama. And so it's a kind of fitting end to the whole book.
It's the interesting thing about both Simpsons and Futurama. There's a lot of people who look at these shows and think, oh, those are fairly lowbrow. There's a lot of potty humor, a lot of sort of football to the groin incidents. But your book reveals that there's actually a lot of high-level comedy going on in there, insofar as, if you don't know about Fermat's theorem, you wouldn't pick it up. But if you do, it's this whole extra level to the show that you can enjoy. Do you think this sort of mix has contributed to the success of the shows?
Oh, well, yeah, I'm sure. And there's more than the mathematics. There are references to a lot of movies, a lot of American politics from the 1970s, a lot of art and literature. And I think all of these things reach out to different constituents. I think the mathematics is truly exceptional, because in many, films and TV shows, you'll find references to politics and philosophy and art and culture. That's part of our society. And so writers will always refer to it. But no other TV show makes references to mathematics, and no other TV show, apart from The Simpsons and Futurama, makes so many and such informed and such highly obscure and arcane references to mathematics. So, I think it does add to the show, and it means that some people watch it for the slapstick humor. Some people watch it for the clever wordplay. Some people watch it for some of the, the touching storyline. But if you love mathematics, then you get an extra little buzz because you notice these occasional references to obscure mathematics.
Simon, thanks so much for being here.
Oh, it's my pleasure. Good to talk to you.
If you want to learn more about Simon Singh and his books, you can visit simonsingh.net. And that link will be available on our show notes at our website at scienceforthepeople.ca. Next up, let's find out how science can help us create the perfect baked good. You may want to have some handy to snack on while listening.
Science for the People is a weekly radio show exploring everyday life from a scientific perspective. To find out where Science for the People airs near you, or to listen to past episodes, check out our website at scienceforthepeople.ca. You'll also find links to connect with us on Facebook, Twitter, and Google+, or to subscribe to the podcast in iTunes. And now, back to the show.
Welcome back to Science for the People. I'm Rochelle Saunders, and I'm joined by Kenji Lopez-Alt, the Chief Creative Officer of Serious Eats, where he likes to explore the science of home cooking in his weekly award-nominated column, The Food Lab. He's the author of the upcoming book, The Food Lab, Better Home Cooking Through Science, which will be released as a 2-volume box set in the fall. Thanks for being here, Kenji.
Thank you for having me.
Now, every person needs a goal, something to strive for, something to safely obsess about. Why did you go with baking the perfect chocolate chip cookie?
Well, for one thing, chocolate chip cookies are delicious. And so obsessing over them is a surefire way to make sure that you're going to have a very delicious month or two. But, to be honest, the main reason I obsessed over chocolate chip cookies, and I fall into a number of obsessions through the course of the year, but the reason I picked chocolate chip cookies this time is because it's one of those things where I would make them occasionally, but I never knew why one batch I made came out better than another, or what mistakes I was making, or how to get a recipe that would sort of lead me to the type of cookie that I personally want. Because I feel like chocolate chip cookies are a really personal thing, because there's so many different styles, and some people like them soft and chewy, some people like them crispy, and so I wanted to really figure out what factors come into play when you're making cookies, and how to control those factors to end up at the cookie that you want.
So how did you go about this noble effort for food science?
I treated it like you would any other sort of science experiment. I baked lots and lots of cookies, over 1,500 of them, over the course of a couple months. And the way I do it is very sort of orderly and organized. So testing one variable at a time, and slowly sort of trying to answer the basic questions before working my way up to the actual final recipe. 1,500 cookies, a lot of them were very bad, and a lot of them were just sort of okay. And then the final few batches were sort of exactly where I wanted them to be.
Let's dive into this a little bit more. Most chocolate chip cookie recipes start with a few main ingredients.
Right.
Butter, sugar, vanilla, eggs, flour, salt, and some kind of leavening agent, and chocolate. So Let's go through them and have you speak a little bit about what you learned. Okay, so let's start with butter. What does it do for a cookie?
First of all, flavor. Butter tastes really good. Butter is basically, it's about 81 to 82% butter fat, depending on where you buy it and what brand you buy. And then it's a small percentage of protein, and that's where most of that flavor comes from, the milk proteins. That's where that clean milk flavor comes from. And then the rest is water. And so butter does a number of things. Aside from flavor, one of the big things it does is it keeps cookies tender. And the way it does that is by coating flour particles in fat. So when you bake a loaf of bread, for example, a loaf of bread gets nice and chewy and stretchy. Because when flour combines with liquid, with water-based liquid, it forms gluten, which is a sort of protein network that is very elastic and very stretchy. And that's what happens when you bake a loaf of bread. There's little bubbles of air and water vapor that get trapped inside this network of gluten, and that's what that's what makes your bread sort of into this sort of solid foam. And the reason a cookie or a cake doesn't form that solid foam is because, first of all, there's very little water in a cookie. Compared to a loaf of bread, a cookie would maybe be under 10% water, whereas a loaf of bread would be more like 60% water. And then the other way that the butter helps is that by coating the particles of flour in fat, it prevents them from absorbing water. So basically, the more butter you use, the more tender your cookie will become.
So how did you test the butter?
The simplest way is to use the traditional cookie method, which is to cream the butter with your sugar. That is, you put it into a stand mixer, or you you beat it with a wooden spoon along with the sugar until it aerates. And this step is in a traditional cookie. The reason you do this is twofold. First, you want to soften the butter so that it can more easily combine with the flour. And then secondly, you want to incorporate some air so that your cookies will leaven a little bit better, stand up a little bit taller when you bake them. And so using that method, you can, the simplest test you can do is just basically testing the amount of butter you use. And by doing that, you find out that the more butter you use, the more tender your cookie becomes, but also the more it spreads out. Then beyond that, the other tests I did were testing whether melted butter makes a difference. And indeed it does, because melted butter obviously can't hold air as well.
Right.
So your cookies spread out a little bit more, but you also end up with slightly chewier cookies. The big step, the big key, and one of the big keys in this recipe is to actually cook the butter until it turns a little brown. And that's those milk proteins, those flavorful milk proteins that are browning in the butter. So by browning the butter before you incorporate it into the cookie, you add these sort of caramel and butterscotch type flavors to it that really make it the finished cookie a lot more flavorful.
Next is sugar. What does it do?
Sugar obviously makes things sweet. Depending on the type of sugar, that sweetness profile can change. So white sugar is crystallized sucrose, which is it's a complex carbohydrate that's made up of a fructose and a glucose molecule that are linked together. And it has a very sort of clean, sweet, but neutral flavor. There's not much going on there. Brown sugar, on the other hand, is similar to sucrose, but it also contains a small amount of individual pieces of glucose and fructose molecules. And glucose and fructose molecules individually are actually sweeter than they are combined into sucrose. So brown sugar, weight for weight, is slightly sweeter than sucrose than regular table sugar is. And it also has a lot of molasses still coating the individual sugar grains, and that gives it a sort of slightly bitter and a little more rich and complex flavor. So sugar, it plays a big role in flavor. The other important thing that it does is that it's depending on the type of sugar you have, it has very varying degrees of hygroscopity, and that is its tendency to retain moisture. So you'll see that simply by switching out white sugar with brown sugar in an otherwise identical cookie recipe, the brown sugar cookie will retain a lot more moisture as it bakes. And the end result of that is that you get a sort of chewier, softer cookie. By balancing out the amount of brown sugar and white sugar you use, you can affect both the flavor of the final cookie as well as the texture. Corn syrup is pure. It's pure glucose. So there's no sucrose in corn syrup. It's made purely of fructose and glucose and depending on the type of corn syrup you get, it'll be different ratios of them. But it's pure fructose and glucose, which means that it is extremely hygroscopic. Corn syrup, out of all the sugars you can use, is the one that'll retain the moisture the most. So not only will it create the chewiest cookies, it will actually also caramelize a lot faster than regular sucrose will, because if you imagine, so the process of caramelization is when you take sugar and you apply heat to it, and then through the application of heat, it breaks the sugar down into various smaller subcomponents that then recombine, and you end up with hundreds of new compounds, and it adds complexity and sort of these caramel flavors to it. But if you imagine if you imagine a sugar molecule like a sucrose molecule as, say, like a building constructed out of Legos, if you want to caramelize it, what you do is you first break it down into the individual pieces or little bits of a few pieces of Legos stacked together, and then you recombine those Legos into new molecules. So it's a process of deconstruction and then reconstruction. So the smaller the pieces are to begin with, the faster that process takes place. And since fructose and glucose molecules are smaller than sucrose molecules, they actually caramelize more readily because they're easier to break down and recombine. So you'll find that if you make something with brown sugar, it caramelizes faster than white sugar will. And if you make something with corn syrup, it'll caramelize even faster.
On to vanilla. Now, it doesn't do anything other than add flavor, right?
Yeah, vanilla is a flavoring agent. It's when you get natural vanilla, it's derived from the vanilla pod, which comes from a type of tropical orchid, and it's made from the seeds inside that pod. And natural vanilla, the primary flavoring molecule in there, the one that you smell and identify as vanilla, is called vanillin, appropriately. But it also contains several hundred very minor components that add a little bit of complexity to its aroma. Imitation vanilla, on the other hand, is basically pure vanillin. So it doesn't have those other compounds in it that makes it complex. So imitation vanilla has a very strong vanilla flavor, but it's also very simple. Whereas natural vanilla has a weaker aroma, but is more complex. What we found in several taste tests, not just with cookies, but in several taste tests, is that generally, if you're baking, most people cannot tell the difference between imitation and natural vanilla extract because there's so much else going on in a baked good that all those tiny minor components of natural vanilla, they get completely lost. Which is actually good news because imitation vanilla extract, the flavoring molecule is exactly identical. It comes from a different source, but it's identical. And it's about 10 times cheaper than regular vanilla.
Okay, on to the eggs. How do eggs affect a chocolate chip cookie?
When you look at an egg, I mean, you have to realize that eggs are actually two separate ingredients really that you're adding. You're adding egg yolks and egg whites. Egg whites are mostly water, but they also have quite a bit of protein. The egg white proteins are actually really good. Like the one thing that they're excellent at is forming these networks that trap and retain bubbles of air. So that's why, like in an extreme case, you can make like say a meringue or a souffle, where egg proteins, very actually quite similar to the way gluten would work, but a little bit, but not quite as tough as gluten. But they trap air bubbles so that when you whip air into something and then subsequently heat it, it'll puff up a little bit. And so this sort of keeps cookies light. They're one of the physical leavening agents that you would use in a cookie. And then they also add a little bit of that water content. In a basic chocolate chip cookie recipe, the only place that water is entering it is from the small amount in butter and from the water that's in eggs. So without eggs, you would have cookies that are almost crumbly because you need that water for a little bit of gluten formation. And then egg yolks also provide a little bit of liquid and protein. But the more important part is that egg yolks have fat in them. Fat will also help to keep cookies tender and sort of give them, they have the fat and protein in egg yolks has a different texture than the fat and protein you would get from butter and egg whites. And egg yolks tend to bake up a little bit sort of fudgier, giving you a little bit more dense chewiness. So if you want sort of fudgier, more sort of brownie-like cookie, you would add more egg yolks to your cookie mix and less egg whites. And if you like a sort of taller, less dense cookie, then you would add more egg whites. And obviously, if you want something in between, which is what I like, then you would add just whole eggs.
So what about flour? What did you do there?
You can buy a few different varieties of flours in the supermarket. All-purpose flour is the most common, and flours really the main difference between different types of flours is their protein content, and that in turn is indicative of how easily they'll form gluten. So in the supermarket you'll see pastry flour, which is also called cake flour sometimes. You'll see all-purpose flour, and you'll see bread flour. Now, bread flour is very high in protein, and that's because you want to be able to form a lot of gluten so that your bread will be nice and chewy and rise up well in the oven. Cake flour and pastry flour, on the other hand, is very low in protein, and that's because you want your baked goods to be nice and tender and to not be extremely chewy. So all-purpose flour is in the middle, and it's designed to work well in bread recipes, but not as good as bread flour, and work well in cake recipes, but not as good as cakes. For the sake of this recipe, one of the big parameters I always take into account when developing a recipe is how a home cook is going to work. And so limiting the number of specialized ingredients and just limiting the total number of ingredients is a big goal for me. Like there's no point in making a recipe if it's so much of a hassle that nobody's gonna make it. So I sort of decided off the bat that I wanted to make sure that this recipe I'm developing works with all-purpose flour. Mm-hmm. So basically, it was one of those things where I just sort of decided at the beginning, like I'm using all-purpose flour. I'll make everything else work around that, so that everybody's going to always have the ingredients on hand to make this at home.
Okay, on to what many people would consider the most important part of a chocolate chip cookie, the mm-hmm. chocolate. But how much can you really play with that? Chocolate
obviously comes in many different cacao content counts, so you can get 72% cacao, 100% cacao, and it comes in different sweetnesses. It comes in either dairy or dark. All these things. But, in reality, a lot of those things come down to just personal preference, whether you like milk chocolate or whether you like dark chocolate. The main factor that I think really affects on a physical level the way a cookie bakes is how the chocolate is incorporated. So a classic chocolate chip cookie has the chocolate obviously incorporated in chips. And those are small and very clean and very easy to kind of fold in. And when you bake a cookie that has regular chocolate chips in it, you end up Well, with a lot of sections that are just sort of clean cookie and then a lot of like little pockets of melted fat. What I found is my favorite way to incorporate chocolate is to start with bars and to chop them up by hand so that you have a mix of really big chunks and then almost powder, almost chocolate powder. And when you incorporate this into your dough, you end up with sort of a lot more integration of the chocolate into the final cookie. So you do get those big chunks, but you also get sort of thin layers of chocolate, and you get little, like really tiny pockets of chocolate. And it just, to me, it makes a much more interesting overall experience at the end.
Okay, so what about salt?
Salt, I think, could be the number one thing that that many home bakers either forget to add or don't think is necessary to add to baked goods, because you think chocolate chip cookies are sweet. Why would I add salt to it? You'll find that when you add salt, just like it does with savory foods, that salt really brings out a lot of other flavors. It makes your mouth sort of more primed to taste things and to smell things. It gets your saliva flowing. Like it just makes everything easier to sense on your tongue. No matter what I'm making, even if it's a completely sweet baked good, I always try and balance the amount of salt in it. And chocolate chip cookies in particular do quite well with a bit of salt, because they have that sort of caramelly flavor, and salt and caramel are sort of just a classic pair. My cookies end up with a significant amount of salt in the actual dough, but more importantly, I finish them while they're baking with a little bit of really coarse, crunchy sea salt. And that creates these sort of little pockets of, just like you have pockets of gooey chocolate in the cookie, and little crunchy bits of caramelized sugar around the edges of the crust of the cookie. This creates a little bit of that salty, crunchy, salty bits, so that as you're biting it, you get these little bursts of flavor all around your mouth. Like this one is sweet, and then you get a nice salty one, and then you get this gooey chocolate one. It makes eating the whole eating experience a lot more interesting.
Oh, so hungry. So what about leavening agents? How important are they?
Just like with any other ingredient in the cookie, you find once you start playing with them, you find that a leavening agent actually does a lot more than simply leaven a cookie. It was amazing to me like how complex a system a cookie is. It's almost impossible to simply change one variable without completely affecting everything else, because it's a sort of interconnected series of reactions that goes on in there as it bakes. So you do find that with every ingredient, it's doing more than one thing. And in a cookie, like the classical leavening agents are baking soda or baking powder. Baking soda is pure, it's sodium bicarbonate. It's pure, it's an alkaline powder. And what happens, and the way that works is that by when you incorporate it into a dough or a batter, as that dough or batter softens up in the oven and releases moisture, the baking powder dissolves, and then it reacts with whatever acidic components you have. In the case of the cookie, it's reacting with some of the stuff from the chocolate that's coming out, the alkaline treated chocolate. So and when it reacts with the acid, it produces carbon dioxide gas, and that's what the bubbles are that sort of leaven a cake or a cookie. Baking powder, on the other hand, contains some amount of baking soda, some amount of sodium bicarbonate, and then it also contains a couple of powdered acids, so that it's sort of like an all-in-one type thing. So baking powder, all you have to do to get it to react is mix it up with water, and when the sodium bicarbonate and the powdered acids in there combine with each other, they just react on their own. So the general rule is that when you're adding baking soda to something, it's going to require some other acid source in the dough or in the batter, whereas baking powder is something you would add if you don't have any other acid source. But by changing the ratio of them, you can also get other effects. For instance, baking powder, because browning reactions, the Maillard browning reactions, which are the same reactions that turn, say, when you're grilling a steak, it's what turns the outside of a steak brown. It's the same reaction that creates a crust on a loaf of bread or gets your cookie to caramelize and brown. Those reactions take better in slightly alkaline conditions. So you'll find that the higher proportion of baking soda you use to baking powder, or just to the overall cookie, that the better your cookie will brown. Baking soda and baking powder also react at different temperatures. So baking soda reacts almost immediately. As soon as it dissolves and meets an acid, it'll react. Baking powder, on the other hand, is what we call double acting, and that means that it reacts once immediately, and then it reacts again once it reaches a certain temperature threshold. So you'll find that with baking powder, your cookies will rise a tiny bit at the beginning as soon as you place them in the oven and they start to soften up. But then once they hit a second temperature threshold, they'll sort of rapidly bubble up and rise significantly. So what the end result is that with baking powder you get sort of a taller, more sort of cakey rise, whereas with baking soda you end up with a flatter cookie. It turns out that a mix of the two, it will give you sort of the ideal final state. But it all depends on what you're going for.
So let's be clear. What you discovered throughout this process was the best chocolate chip cookie recipe for you, and that's something that's fairly subjective. Mm-hmm. I'm assuming someone could use the same process to find their best possible chocolate chip cookie recipe, but it does seem quite lengthy. Is there any suggestions you have, or what you think might be global chocolate chip cookie qualities?
That's tough to say. I mean, I really can't think of a global quality because there are so many different variables in chocolate chip cookies and so many ways that people like chocolate chip cookies. What I was considering doing, and I still probably will do at some point, is that in the process of developing this recipe, I sort of devised this sort of spreadsheet that I have where I was keeping track of what each test of the results of each test and what changing each element does. And so I sort of have almost a formula for chocolate chip cookies that of various types. So I can look at my chart and say all right, if I want a chewer chocolate chip cookie, I'm going to change the ratio of white flour to brown sugar. I'm going to change the ratio of egg whites to egg yolks, and I'm going to change the way I cream the butter. Whereas if I want a crisper cookie, I'm going to do X, Y, and Z. So I'm working with one of our web developers right now on sort of making this into an interactive sort of website where you go on and you say what kind of chocolate chip cookie you like, and it'll just spit out a recipe at you that's based on all these variables, so that you can sort of even without reading the entire whatever is 7,000 word article and trying to understand each and every element. Where if all you want is a really crispy, thin chocolate chip cookie, you can come to this site and just say give me a recipe for a thin, crispy chocolate chip cookie, and it'll automatically calculate how to alter all these variables to produce that result. So my global advice would be to wait for that website to come out and then visit it. But no, I think the real answer is that so long as you're following a basic ratio of ingredients and a process that's been sort of tested and true, even the worst chocolate chip cookies that come out based on that method are not terrible. So my advice would be to just jump into the kitchen, and the worst thing that can happen with a chocolate chip cookie experiment is that you end up with a chocolate chip cookie that's just slightly less delicious than the best chocolate chip cookie, and even that's not such a bad end result for an experiment, I think.
And there is nothing that friends like better than free chocolate chip cookies. So go forth into your kitchen and bake.
Yeah, or 1,500 free chocolate.
Yeah. Who ate all those cookies?
I give my kitchen experiments mostly to my doormen. This happened to be during the holiday season that I was testing it too, so I could give them away to friends and my parents and my grandparents. Basically everybody I know ended up taking home cookies at some point or another.
Kenji, thanks so much for being here today.
Thank you for having me.
We've linked to Kenji Lopez-Alt and the Food Lab at Serious Eats on our website at scienceforthepeople.ca. Desiree Schell will be back after the break to talk with Chris McKinlay about how math and OkCupid helped him narrow his dating pool.
On the next episode of Science for the People, we're looking back at 4 remarkable minds whose weekly meetings set the stage for a revolution in science and technology. We're joined by science historian Laura J. Snyder to talk about her book, The Philosophical Breakfast Club, 4 remarkable friends who transformed science and changed the world. And we'll speak to Shirley Amy Davis Roth and Skepchick contributor Melanie Mallon about the science track at Convergence 2014. That's next week on Science for the People, on your local radio station, or online at scienceforthepeople.ca.
I'm Desiree Schell, and I'm joined by Christopher McKinlay, who received his PhD in mathematics from UCLA in June of 2013. He's currently doing postdoctoral research in machine learning and computational metagenomics at UMN. Chris, great to have you here.
Thanks for having me on.
So let's start with some background. How does OkCupid work?
So OkCupid is a free dating website, and their revenue model is built largely on ads. And they have a really great kind of content team, and it's a fun site to use. And basically how it works is, you sign up, you make a profile, and then you can either just go around and see whoever else is on the site. They don't block anyone from you. Everyone who's on the site, you can go, but you're encouraged in various ways to start answering match questions. And these are all questions that are submitted by users on the site. There's over 200,000 of them. So there's a lot of questions, but they're all, and they cover all sort of walks of life. I mean, everything from is the earth bigger than the sun, to would you ever have a threesome, to do you not eat chicken? I don't know, just everything you could possibly imagine. But they're all multiple choice questions. And the way the site's matching part works is, for every question you decide to answer, there's three parts. You select an answer for yourself, and then you select one or more answers that would be acceptable to you for someone you're looking to meet. And then you lastly assign an importance value to the question, which reflects, how important you think it is to you. And then based on the questions you answer and say a person that you are looking at, OkCupid will generate what's called a match percentage, which is just a number between 0 and 100. And that's kind of the number that drives the whole site. When you search for anything, say people, over 6 feet with blue eyes or something like that, the results come back. They're essentially ordered by these numbers, by match percentage.
And so what problem did you have with that system that you decided to manipulate?
The problem I had, and I think it's the same problem that everyone has, is that OkCupid, like I said, that they make money on ad revenue, and every time that you click on a new question, they serve you a new ad. So for them, they treat questions a little bit like clickbait, and the questions are always really entertaining, so there's this tendency to kind of get swept up in the website and maybe look at someone's profile, fall in love with the profile a little bit, see what questions they answered, and then you can only see someone else's answer to a question if you answer it yourself. So if you see some really wonderful looking guy and he's answered this question, and you really want to see it, but you haven't answered the question yourself, you have to answer it. And so if you're just kind of on it casually, which is what I was before I started thinking about it like a data scientist, you end up just answering questions in a sort of ad hoc fashion, which generates a lot of ads for them, but actually doesn't give you very much visibility on the site from a data perspective. It doesn't position you very well.
So when you started looking at it from a data scientist perspective, what did you do?
I was working on my thesis at the time, which was also something that was dealing with clustering large amounts of high-dimensional data. And, it was just kind of these two things were in my head at the same time. So there was some cross-pollination, and I realized that OkCupid was something that I could actually apply tools that I was very familiar with to in a very different way. And so I reasoned that, my experience on the site was probably to some extent the average experience, and that when a bunch of people go and answer questions like this, the answers aren't uniformly randomly spread across the entire space. They tend to cluster together because we're social creatures, and our beliefs tend to be clustered around certain, I don't know what you would call them, archetypes or something.
Right.
And so in order to test that hypothesis, I needed to collect a lot of data from users, so I needed all of the questions and all of their answers, and other metadata like, their age, location, basically everything I could get. So I wrote software that essentially just automated the process of someone creating a profile, logging on, and then going around and answering questions that other people answered, and then just recording their answers. The software I wrote is something that anyone could do, except that I collected, over 6 million answers to questions.
What were you trying to do with that survey data then?
Well, I was just trying to see if their answers did in fact cluster. So, I wanted to take a large group of answers to questions and apply some high dimensional clustering algorithms to them to see if I could identify, a small number of sort of archetypal question signatures that users, adhered to some extent. So yeah, I wrote bots to do this. They got kicked off, and then I wrote more intelligent bots that didn't get kicked off. After a couple of weeks, had a pretty sizable data set, and I found that when I clustered it, 20,000 women answering questions really just fell into 7 different kind of categories, you could say, or clusters.
Based on what kind of similarities?
Just in terms of the data, it just means that they all tended to answer the same questions the same way. Now, that translated into other kinds of similarities outside of the question data. For example, there's a group of women who are in their, late 20s. The average number of tattoos was slightly more than 2, Average income was slightly less than $30,000 a year. Often had one paying the bills type of job and another very much creative job like musician or something.
Right. Let's move ahead here. So the 7 distinct clusters, you chose 2 of those clusters.
Yeah, so once I'd clustered all the question data, I started looking at some of the profiles near the centers of these clusters just to get a more empirical feel for what I was looking at in terms of profiles. And the 2 largest clusters on the site were 2 that I felt really sort of comfortable, like they were my peeps or something, or they seemed like the best places to look for possible matches.
Right.
And so I was able to figure out from those clusters which questions they thought were important. That was about a few thousand questions for each profile. And so once I had that information, I just went and answered those questions honestly. I provided an honest answer for myself. If it was a question that I thought my honest answer was not going to fly, I just wouldn't answer it. But that rarely happened because of the way that I picked the clusters. It was generally people that I don't know who valued questions that I also valued.
Right.
So the thing that I used a lot of math to do was to decide how I weighted the questions, like the importance levels I gave them, and the answers that I chose to be acceptable from a possible match for me.
And this is where I have to put away my cynical side altogether, because you actually did meet someone special.
Yes. So, like I said, I had this project-based mentality about this, and it kind of it left the mathematical domain and entered the sociological domain pretty quickly, and holding on to it, I sort of became a little bit of a sociologist. I was writing all the information about these dates down in notebooks, and thinking that I would probably meet someone and I in this way. But after the first 50 or so dates, I was saying no a lot. I'd only said yes to maybe 2 second dates in that time. It became a little bit alienating in a way, because everyone I met with, they're all very different, because people aren't their profiles. But in another way, they're all very similar, because they'd all answered thousands and thousands of questions about all different things in a statistically significantly similar way.
I have to ask, what does your partner think about this? About the fact that this is how you met?
When I met Christine, I immediately felt completely different. She felt like a kindred spirit, and she told me on our first date that she'd changed her profile before she messaged me, because she wanted me to write her back more. And I had a couple of very honest things on my profile, so she put something kind of similar on her profile, and once she told me that, I sort of spilled the beans on my project, and made for a really interesting date, but she loved it. I mean, she thought it was, like you, I think maybe a little cynical. I myself think it was a little cynical, but she also thought it was hilarious, and we really hit it off.
Has OkCupid responded to this story at all? Because they must know about it right now. Kevin Poulsen's piece in Wired, which is where I read about you in the first place, that must have triggered like a Google alert in OkCupid headquarters or something. Has anybody contacted you?
Yeah, I actually reached out to one of the founders who I have a friend in common with, Christian Rudder, who's the guy who wrote their really excellent blog, OK Trends. He was one of the co-founders, and he was also contacted by Good Morning America, who ran a piece on me last week, and his quote, which I think is OkCupid's official quote, and it was really charming and low key. It said something to the effect of, it sounds like what he did was really great, and as long as people aren't hurting other people or disrespecting them, then we're happy to be quote unquote hacked, so to speak. Our main interest is in helping people meet each other and get dates, and that's one of the reasons I'm really a big fan of OkCupid as opposed to some other very closed sites with sort of proprietary black box matching algorithms like eHarmony. They're not going to ever tell you why this person's supposed to be your soulmate. They're just going to, tell you and back it up with a bunch of non-peer reviewed pseudoscience that this is in fact your soulmate.
Have you thought about marketing this as some kind of software package? Because every single person that I mentioned this story to asked if it was for sale. And my sample is admittedly biased.
I wrote a book on how to implement what I did. And I wrote it for a lay audience, someone without a math background or a coding background, because the collecting the data and the clustering part was technically difficult, but the insights that I came away with are things that anyone can use. And so I wrote in a very detailed fashion a specific algorithm called simulated annealing, which you can implement yourself, not by writing code, but just by following my instructions in what to do and how to answer a few hundred questions. And in doing that, you will be constructing a sort of curated set of questions and answers that will position you in this high dimensional space so as to kind of give yourself optimal visibility to the people that you're interested in meeting. And that's not something you're going to be able to do by answering the questions that OkCupid feeds to you. They've got their own interests, like business metrics, lifetime value and things like that. And I think it's really a question of people just going about the question answering process in a more directed and sort of algorithmic, for lack of a better word, deterministic way.
What do you think your chances would be that you would have met your partner without hacking OkCupid?
Small to none. It was all about visibility. She did a search for guys who were taller than 6 feet with blue eyes, and I was coming up at the top of almost every search run by about 20,000 women in Los Angeles. So I was extremely visible on the site, and if not for that, we would never have met. On the other hand, I don't one thing that didn't come out in the Wired article, but I think is important to say, is that I wasn't really in any kind of driver's seat during this process. When I met Christine, she was in an open relationship with a man and another woman. And that was really a tough pill to swallow for me at first, because I knew for sure that I really wanted to be in a relationship with her where I felt safe, and I wanted to shut this whole thing down. But it was a whole different set of challenges. And the reason that we're engaged now isn't because I did something fancy on a website. It's because we became really good at reconciling our differences and growing together, just like anyone else.
Chris, good luck, and thank you very much for being here. I'm still torn, but congratulations.
Oh, thank you very much.
And if you want to read more about Chris McKinley's story, we've linked to Kevin Poulson's Wired piece on our website at scienceforthepeople.ca.
And that's all from us this week. You can visit us at scienceforthepeople.ca, and while you're there, click the links to Facebook, Twitter, and Google+, and over to iTunes, where you can listen to past episodes, subscribe to the show, or maybe even leave us a glowing review. Thanks for listening, and see you next week on Science for the People.
Science for the People is recorded in Edmonton, Alberta. The show is produced by Rochelle Saunders. Ryan Bromsgrove is our promotions manager. Our social media manager is Chelsea Butler. K.O. Myers updates our website. Helen Quivalon is our publishing liaison. Ed Haynes is our guest coordinator. We get research help from Josh Witten. The show is edited by K.O. Myers and Ryan Bromsgrove. Our theme song was written and recorded by Fractal Pattern, and its title is Binary Consequence. The show is hosted by Rochelle Saunders, Marie Claire Shanahan, and me, Desiree Schell.